Hey everyone, we're going to do some more notes on waves. Shoot, no. Hey everyone, we're going to do some notes on waves. And to start off, we're going to set up our page. It's been a long time since we've taken notes. So let's set this up again. We have a line along the side here. And then two along the top. We have this little section over here where you put your name and then the date. What is it? 3/15/21. And we're going to talk about waves. Waves. Fix my light quick. Okay. So our essential question for today is what kinds of waves are there? Question mark. So what kinds of waves are there? And we're actually going to find out that there are two different categories that we're going to talk about. So first, let's define what waves are. Waves. So, okay, everything's still good. Waves, first vocab word. So waves, they are a rhythmic disturbance that carries energy without carrying matter. So, rhythmic disturbance. So, like if we were to push a bit of water or make a splash, it's going to cause an up and down motion and it's going to cause a rhythm. So, like kind of a repeating sort of thing. And it's going to carry some energy, but it's not going to carry any matter. So that water that's here, even though it's going up and down, it's not going to move with the wave. It's just going to stay here and push on that energy. So that's a wave. And then we're going to get to the first kind of wave, and that's a mechanical wave. So a mechanical wave is something that has to have matter or a medium in order to transfer that energy. So it's going to say uses matter or a medium to transfer energy. So we're going to have some examples for this one. And for this one, it's pretty easy. Air, water, or metal. So we have a gas, a liquid, and a solid. So they can travel through all of these things, and it would be considered a mechanical wave. And this can actually get split up as well. So for a mechanical wave, we have a longitudinal or compressional. Compress is like to squeeze something. So a compressional wave. So these are interchangeable. That's why I'm writing both of them. But this is going to be, I'm just going to put the definition here. And this is matter. So this is still technically a mechanical wave. So it's matter that moves back and forth in the medium. Now, when we usually think of waves, it's going to be like an up and down sort of thing. This one's actually going to be back and forth. So like a spring, when it's this straight line, if I push one side, it's going to squeeze in a little bit or compress, and that's going to follow along. It's not going up and down, it's going side to side. So it's kind of cool. So we're going to draw a picture of this after I do my example. Sound waves act this way. So we're going to draw a picture for this. And then we get further apart. And then we get closer together again. So we have this area here where it's compressed, and then this area here where it's stretched. So it kind of creates this wave as it moves along. And then the other kind of mechanical wave is a transverse wave. All right, so a transverse wave, we're actually going to break it up into its parts. So we have the crest, which is the top of the wave, and then we have the trough, which is kind of like a pig trough, and that's the bottom of the wave. And then amplitude. The amplitude is the distance from the equilibrium to the crest. Now we haven't gotten to equilibrium yet. We'll get there. Wavelength. This is the distance from crest to crest. And then finally we have equilibrium. Equilibrium, okay? And that's the neutral position of a wave. V. Okay. So these are all parts of a transverse wave, but now we need to draw that transverse wave. So the first thing we're going to draw is our equilibrium. So that's a straight line, it's neutral. So this will be our equilibrium. Okay, then we have to draw our transverse wave. I'm drawing a few more than I need to. That's okay. Let's just keep going. All right. So we have from this point to this point. Well, this is a crest. Hold on, maybe I should have identified that. Crest. Trough. This point to this point is a, so crest to crest would be a wavelength. And then the last one is from here to here that is our amplitude. So you need to know all of the parts of a wave. So the crest is the top, trough is the bottom, wavelength is from where it starts to where it starts again, or crest to crest. We could also go trough to trough, or this point to this point. Not this point, that's halfway, because it's going down versus going up. Amplitude from that crest to the equilibrium. So basically it's how tall the wave is. And then the equilibrium is just kind of that middle part where it's like neutral. If I were to cancel this one with this one, it would equal 0, you know? So anyway, those are the different kinds of waves. We actually have another different kind tomorrow. So these are all different kinds of mechanical waves. Maybe I should have started with that. Anyway, go ahead and copy this down, and I'll talk to you tomorrow.